Welcome to the heart of industrial power, where we witness the incredible journey of turning raw iron ore into the very backbone of our modern civilization. This massive facility operates around the clock, utilizing state-of-the-art technology to process millions of tons of raw materials into high-quality structural steel. The process begins here at the storage yard, where giant machines handle the heavy lifting of raw iron ore, the essential primary ingredient for steel. Raw ore is carefully sorted and filtered to ensure only the best material enters the production line, maintaining the purity required for the high-strength alloys. A network of conveyor belts stretching for miles transports a precise mix of iron ore, coal, and limestone toward the next stage of the smelting process. Each material plays a vital role. While iron ore provides the metal, coal acts as fuel and limestone helps remove impurities during the intense heating process. The raw materials are combined in massive blending bins, ensuring a consistent chemical composition before they are fed into the mouth of the giant blast furnace. The precision of this mixture is critical, as even the slightest variation in the ratio of ingredients can affect the final quality of the finished steel. From the high-tech control room, skilled operators monitor every aspect of the automated feeding system, ensuring a steady and efficient flow of materials into production. Stage 1 is complete. The raw earth has been gathered and prepared. Now we enter the intense heat, where the real transformation of the metal begins. We have reached the heart of the plant, the blast furnace. Here, temperatures soar to over 1,500 degrees Celsius to melt the iron from ore. Inside this towering inferno, a chemical reaction occurs as the carbon in the coal strips the oxygen from the iron ore, leaving behind pure metal. The sheer energy contained within these walls is staggering, creating a landscape of fire and light that defines the very essence of heavy industrial manufacturing. Suddenly, the tap hole is opened and a river of molten pig iron begins to flow, glowing with an intensity that illuminates the entire dark factory floor. This liquid gold is the first form of iron produced, known as pig iron, which will soon be refined further to become the steel we use. The molten metal moves with incredible weight and momentum, guided by heat-resistant channels that direct the fiery stream toward the waiting transport ladles below. Watching this flow is like observing a volcanic eruption controlled by human ingenuity, a testament to our ability to harness the rawest forces of nature. Brilliant sparks fly in every direction as the white-hot metal splashes against the runners, creating a spectacular display of industrial power and raw heat energy. Every drop of this liquid represents hours of processing and the consumption of massive amounts of energy to extract the iron from its original rocky form. Safety is paramount. In this extreme environment, where workers must wear specialized gear to protect themselves from the incredible radiant heat of the molten iron. Once the ladle is full, it carries dozens of tons of liquid metal, ready to be moved to the next stage of the refining process quickly. Automation plays a key role here, as robotic sensors take precise samples of the molten metal to ensure the chemical balance is perfect before moving on. The data collected allows engineers to determine exactly how much oxygen and which alloys need to be added to create the specific grade of steel. The pig iron is now ready. It is hot, heavy, and full of potential as it heads toward the basic oxygen furnace for its final transformation. Now we enter stage 3, the refining. The pig iron is poured into the basic oxygen furnace, where it will finally be transformed into steel metal. This process is incredibly violent and powerful, as the molten iron reacts with the environment inside the furnace to burn off excess carbon and other impurities. The vessel is a masterpiece of engineering, designed to withstand the extreme chemical reactions and heat generated during this critical phase of the steel-making process. A high-pressure stream of pure oxygen is blown into the metal, igniting a firestorm that rapidly lowers the carbon content of the molten pig iron. The reaction is so intense that the temperature actually rises further, reaching levels that make the metal glow with a brilliant, almost blinding white light. Every second counts during the blow, as the timing must be perfect to achieve the exact carbon level required for the specific type of steel produced. As the impurities are oxidized and removed as slag, what remains is a highly purified form of iron that we now recognize as liquid steel. To give the steel its final properties, various alloys like chromium, manganese, or nickel are added, tailoring the metal for its future use in construction. These additives determine everything from the steel's strength and flexibility to its resistance to rust and corrosion in harsh environmental conditions over many decades. The liquid steel is now tapped, flowing out with a brilliant clarity that distinguishes it from the rougher pig iron we saw earlier in the process. This molten steel is now a sophisticated alloy, carefully crafted to meet the rigorous demands of modern engineering and the highest global safety standards for infrastructure. One last check ensures that the chemistry is exactly right before the metal is cast into solid shapes that can be handled and further processed. The liquid phase of our journey is nearing its end as we move toward the casting floor, where the steel will finally take a solid form. This is the moment of transition, where the chaotic energy of the furnace is brought under control to begin the process of shaping the future. Stage 4 begins with continuous casting, a modern marvel that allows liquid steel to be shaped into solid sections without ever stopping the production flow. As the metal passes through water-cooled copper molds, a thin solid shell forms on the outside, supporting the heavy liquid core as it emerges. The steel moves in a continuous ribbon, guided by rollers that maintain its shape while it slowly cools and hardens throughout its descent through the machine. This massive strand of hot metal is now becoming a manageable shape, ready to be cut into specific lengths for the final rolling and shaping processes. Intense water sprays are used to rapidly cool the steel, creating a dramatic atmosphere of steam and mist that fills the entire casting area of the plant. This cooling process is carefully controlled to prevent the steel from cracking or developing internal stresses that could compromise its structural integrity in the future. The steel is now solid enough to support its own weight, yet it remains hot enough to be easily shaped by the powerful machines that await. Automated gas torches now move into position, ready to perform precise cuts on the moving strand of steel to create slabs or billets of exact length. The cutting process is synchronized with the speed of the casting, ensuring that every piece of steel is uniform and meets the production specifications perfectly. Even after being cut, the heart of the steel remains incredibly hot, holding the thermal energy that will be needed for the final rolling process. These individual pieces, called billets or slabs, are the raw building blocks for everything from construction beams to automotive parts and household appliances. The precision and speed of the continuous casting process have revolutionized the steel industry, making it more efficient and consistent than ever before in history. Each billet carries a unique ID, tracked through the system to ensure quality control and traceability from the raw ore to the final finished product. We have successfully turned liquid metal into solid shapes. Now it is time to use brute force to roll these shapes into finished steel products. Welcome to the rolling mill, the final major stage of production where massive mechanical force is used to shape the steel into its final form. The steel is reheated if necessary and then passed through a series of heavy rollers that squeeze and stretch the metal into thinner and longer, shapes. With each successive pass, the steel becomes stronger as its grain structure is refined by the intense pressure of the rollers spinning at high speeds. The heat and pressure are immense, requiring constant lubrication and cooling to keep the high-precision rollers from wearing down under the extreme mechanical stress. In the final stages, the steel bar can reach speeds of over 100 kilometers per hour, flying through the mill like a fiery dragon. Specialized rollers can add textures, such as the ridges found on rebar, which help the steel bond more securely with concrete in large construction projects. Other mills produce flat sheets, which are rolled into massive coils weighing several tons, ready to be shipped to automotive factories or appliance manufacturers. The precision of the thickness is measured in microns, ensuring that every meter of the coil meets the exacting standards required for high-precision manufacturing. Robotic systems handle the finishing touches, securing the coils and moving them with ease, showcasing the seamless integration of heavy industry and advanced robotics. Bundles of rebar are automatically counted and tied, ready to be loaded and sent to construction sites where they will support the world's tallest buildings. Every piece of steel is marked with its unique digital identity, allowing for full traceability back to the specific furnace heat from which it was born. Quality is the final word in this factory. Every product is inspected to ensure it meets the strength and durability required for its critical intended application. From raw ore to finished product, the transformation is complete. But before it leaves the plant, it must pass the most rigorous of tests. In the quality control lab, samples are pushed to their breaking point to verify that the steel possesses the exact strength and flexibility required by law. At the microscopic level, we can see the results of our hard work, a perfectly balanced structure that gives steel its legendary durability and toughness. Only after passing these strict inspections is the steel certified for use, ensuring the safety of every bridge, car, and skyscraper built with our metal. Our finished products wait in the vast shipping yard, a testament to the scale of human production and the global demand for high-quality steel. Logistics teams work with precision to load the heavy cargo, coordinating the departure of thousands of tons of steel every single day of the year. Long trains carry our steel across continents, feeding the hunger of growing cities and connecting people through vast networks of rail and road infrastructure. As the steel leaves our gates, it begins its new life, becoming a part of the world's most impressive architectural and engineering achievements for generations. The people who work here take immense pride in their craft, knowing that their hard work forms the very skeleton of our modern world's growth. As the sun sets, the furnace continues to roar, a symbol of human progress that never sleeps, constantly building a stronger and more resilient future. Steel, the enduring backbone of modern life. Thank you for joining us on this incredible journey from the raw earth to the heights of civilization.